Welcome to The Click. This is Roots Rules Part 3. Okay, so we're on the 10th rule. The 10th rule title is Division of Roots with the Same Index. So when we are in division and when we have the same degree, when both the numerator and the denominator have the same degree, then what we can do, we can divide the numbers inside the root and keep the same root. Meaning that, for example, I have the nth root of a divided by the nth root of b. I can simply write this as the nth root of a divided by b. Okay? And what does this mean? Imagine you have two identical roots, similar roots, right? And then if your roots are the same type, you don't need to make them two separate roots. You only, divide the numbers that are different, and you keep the root. Let's do an example. Okay, so I have the fourth root of 2 divided by the fourth root of 32. I can write this as the fourth root of 2 divided by 32, and I can simply again write this as the fourth root of 1 divided by 16. These two are simplified, and if I raise both my numerator and my denominator to my root, to my degree, it is going to be 1 divided by 2, as the fourth root of 1 is 1 and the fourth root of 16 is 2. Okay, let's go with the 11th rule, multiplication or division by the same value. The index of a root and the exponent of the radicand can be both multiplied or divided by the same non-zero number without changing the value of expression. So for example, both n and m can be multiplied or divided by k, and the value of expression won't change. Why this resonates? Because it's the same as fraction. In fraction, we also had one property, which was multiplication and division by the same number, both for the numerator and the denominator, and the value of the fraction would not be changed, right? And it is the same for roots as well. Let's do an example. Okay, for example, I've got the second root of x to the power of 3. Let's multiply both the degree and the power of my radicand by 2. So 2 times second root of x to the power of 3 times 2. It is going to be the fourth root of x to the power of 6. Going for the third rule, addition or subtraction of the roots. If you want to add or subtract the roots, you cannot add or subtract the degrees of the root or the radicands of the root. The only thing that you can add or subtract is the coefficient. Okay, so to add or subtract similar radicals or roots, simply add or subtract their numerical coefficients. What are numerical coefficients? Well, the numbers that are in multiplication with the root. In here, it's b, and in here it's a, and in here it's b, right? These are the numerical coefficient. Of course, this is a formula, so we're demonstrating it with a letter, but overall, when we have numbers as well, the coefficients are the numbers that are in multiplication with the roots, okay? So why does this matter? Because we can only add or subtract the identical objects, right? And this is basically the definition of addition, for example. In addition, what do we mean by addition? We mean by adding identical objects. So we only can add or subtract the identical objects. So that is why the degrees and the radicands need to be the same in order for us to add or subtract the coefficients. I'm talking very much. Let's go and do an example. So I have, for example, 13 times the second root of 15 plus 12 times the second root of 15 minus 10 times the second root of 15. Let's see where this goes. So both my degrees and my radicands are the same, so I need to only add and subtract the coefficients. So 13 plus 12 minus 10 times the second root of 15. The result will be 13 plus 12, it's going to be 25, minus 10, 15. So 15 times the second root of 15 is our answer, everyone. Okay, let's go for the fourth rule, moving the coefficient inside the root. To move a coefficient inside a root, raise the coefficient to the power of the root's index, okay, and then multiply it by the number inside the root, which is a in this formula. So what we should do, we should raise our coefficient to the power of the root's index, which is n in here, right? So k to the power of n it should be, then multiplied by the number inside the root, okay? So in here I have a as the number inside my root, so I will multiply k to the power of n by a. For example, I have 3 times the fourth root of 3. Okay, I want to move my coefficient inside the root. So what I'm going to do is that I am going to raise my coefficient to the power of my degree. So 3 to the power of 4 times 3. And then multiply it with the number inside the root or with the radicand, right? And the result will be the fourth root of 243. I have a few notes about this rule. If the number is negative, my coefficient is a negative number, and the degree is even, then keep the negative outside, okay? Keep the sign of the coefficient, which is a negative sign, outside, and put the number in an absolute value, in an absolute form value inside the root. For example, I have minus 3 times the second root of 3. Okay, what I'm gonna do is that I am going to keep the negative sign outside the root and then put the number in an absolute value, my coefficient in an absolute value inside the root. So it's going to be in an absolute value 3 times 3, as the second 3 is my radicand. And the second note, if the degree is odd, okay, so the degree in here is odd, at that time put the number inside the root with its symbol, okay? No matter if the symbol is positive or negative, put it with its symbol. So for example, I have minus 3 times the third root of 3, okay? I am going to put this coefficient inside the root with its symbol. So it is going to be the third root of minus 3 times 3. Okay, let's go for the fifth and final rule for this part, radicand with a negative power. This is a very, very simple rule. If the exponent of the number inside a root is negative, as you can see, reverse the fraction. Just that. Just reverse it, because if you remember, we always said this is a rule. This is a mandatory thing that when we have a negative power, we only need to reverse it as a fraction in order for the power to be positive. And no matter if it's in a root or if it's alone, this rule should be followed, okay? So yeah, that is why this resonates. Let's go with an example. For example, I have the 12th root of x to the power of minus 3. How am I going to change this? It will be 1 divided by the 12th root of x to the power of 3. Please remember that 1 doesn't go under my degree of the root, okay? 1 is completely a different number, a separate number. Only x was under the degree of 12. So only x goes under the degree of 12, even after its power is a positive one. We are done with today's lesson. I hope you enjoyed it. See you in the next one, which is the last part of Roots Rules, sources page.